All right, so we've got an idea about equilibrium. We're pushing into this middle point, and most importantly, we're going to where quantity supplied equals quantity demanded. And we're going to go through with a specific example. I made a mistake somewhere in here, but rather than sort through and try and find that, let me just start with a fresh page of paper. So our system here, we've got a supply curve, we've got a demand curve, and both of them are in terms of price. So price here, we've got a positive slope, so this is going to be the supply curve. Here, we've got a negative slope, so this will be our demand curve. And just to see the other direction on this, we can rearrange to get it in terms of Q. All right, so if P equals A plus BQ, well then P minus A, we bring that over, divided by B leaves Q over here. All right, and over here, P minus C, we bring that C over, divided by minus D gives us positive Q. So let's start with the Q equals Q. All right, QD equals QS. This one we said was D. This one is S. Right, so if both of these quantities are going to be the same, we're going to have something dealing with some price. So P minus A over B equals P minus C over negative D. All right, what can we do with this? Well, we want to solve for P. So let me rearrange a little bit. I'm going to start by just separating these bottom parts of the fractions here. So this is P over B minus A over B, right? Exact same thing. And then P over negative D, and actually, you know what, I could call that negative P over D, but I'll leave it there for now. Minus C over negative D. That's probably better. All right, we're gonna leave it like that. So how do we get this P over here? Well, this is a negative term, right? Their price should be positive. Our D we're going to assume is a positive number, but we've got that negative sign. So let's go ahead and just add that to both sides. Let me switch to a color to make this stand out. So we'll say plus P over D on both sides. And then we want to get rid of that A over B. So we'll say plus A over B to both sides. And let's see what we can eliminate. So plus minus, that goes away. Plus minus, that goes away. And let's take what we've got up to this page, tidy up just a little bit. We've got P over D plus P over B equals A over B. And then this is a minus C over a minus D. The C's and the D's, these are positive on their own, right? So this is minus some positive number. So minus C over minus D, well, those are going to cancel out those negative signs, right? So that's going to be plus C over D. All right. What have I got? I've got something I can factor P out of. 1 over D plus 1 over B equals all this stuff. A over B plus C over D. This might be a little bit of a hassle arithmetically to clear this all out. So we're going to divide by this. We're going to move it all around. You know what? Maybe what I should have done is not split this up. Let's take a step back. This is sort of the accidental bumbling process that I use when I try to solve equations. All right, so this was good. So let's multiply the B over. So we're going to have P minus A over B, and then we're going to multiply that by B. So B times what we've got over here, P minus C, which is over negative D. And we're going to multiply both sides by negative D also. That's a negative D, that's a negative D. I kind of smushed them a little bit, but they're not going to stay there for too long. All right, again, let's cancel. This negative D cancels with the negative D, the B with the B. And what have we got here? We've got a negative D PA, positive B, PC. Cool. We don't have any more fractions. This is good. So let me get rid of this negative sign first. So negative D, well, this is the same as saying D, instead of times P minus A, this will be A minus P, right? Let me just make sure of this. Let's say P and A were 5 and 3. So 5 minus 3 is 2, times a minus sign is negative 2. So if we do 3 minus 5, that gives us the negative 2 without needing the negative sign over there. Okay, I'm convinced. I do this sometimes. I'll just kind of plug in some simple numbers into something and just kind of test the numbers in my head to make sure it makes sense. And then we got B times P minus C, and we don't need to do any fancy moving around because there's no negative sign to deal with here. All right, so we still want to isolate those P's. So let's start by saying this is AD minus DP equals BP minus BC. All right, so we're just distributing terms. We want that P. I'm going to add DP to both sides. And then I'm going to add BC to both sides. So that's going to get rid of BC over here and DP over here. All right, now we're getting to something that's starting to ring some bells for me, even though I'm pretty sure I'm doing A, B, C, D in different orders than I've done in other videos. This is why it's good to just write it out, right? It's the arrangement of the elements that matters. It's not the elements themselves. All right, AD plus BC. No mistakes there. BP plus DP. That's good. And this, I'm going to take a step further. This is the same as P times B plus D. And then I can divide. Right, these two terms are the same. So if I'm dividing by B plus D on this, I've got to do it here also. And now finally, I've got P equals AD plus BC all over B plus D. So that is a price. And we can plug that back into, I guess, either of these, and that'll spit out a quantity that should be an equilibrium quantity. But just to be sure, let's go ahead and think about solving the problem this way. And I'm going to try and save some paper and kind of smush this in here. I'm going to say A plus BQ equals C minus DQ. Let's see. I want to move the Q over, so I'll add DQ plus DQ. I'll subtract A. So now I've got BQ plus DQ, and I'm going to skip a step and just factor straight out. There's Q, B plus D. Oh, seeing some echoes. Q times B plus D, this is equal to C minus A. Q equals C minus A over B plus D. So now we've solved it in general, and if you have these and you just get the order right in the setup, then no matter where you're starting from, you've solved for Q star and P star. You just plug in the numbers and you get the answer, and you don't have to do all that algebra again. So these two answers should be giving us the results for what is our P and Q, no matter what numbers we plug in here. Now, let me make sure really quick. So these are all going to be positive numbers over some positive number. So this should be some appropriate price. C minus A. Well, let's see. If C is our demand intercept and A is our supply intercept, here's C, here's A. C should be bigger than A, right? If we've got a market at all, right? So if C is bigger than A, here's C, here's A. If it's not, then we don't have a market. The demand is less than the cost of supplying at all. This is like our market for vacations to the moon. It just costs more than people are willing to pay for it. So if we've got a normal situation, C minus A, this is a positive value over some positive number. Quantity is going to be some positive value. Price is some positive value. That looks pretty good, right? We plug in the right numbers, we should get what we want. So the previous attempt at this video, I ended up with a negative sign here. What that means is that whatever mistake I made had to do with switching a sign somewhere. Here's what it was. I had an AD minus a DP, but plus a BC. That should have been plus, that should have been plus, that should be plus. And so for these specific numbers, 3, 2, 100, and 1, our P star should be 235 over 3. And our Q should be C minus A is 65 over B plus D is 3. So 65 over 3 should be our Q. Cool. So we have solved the basic equilibrium, but we haven't done any of the fancy scenarios yet. So let's stop for a sec, make sure we understand everything, pause, copy through this, follow along, make sure you didn't lose any negative signs, and then we'll come back and start talking about shifting curves.